What if I told you that there might be a black hole so massive that it could literally be bigger than our entire observable universe? And what if that black hole could actually contain entire universes inside it, spawning reality after reality in an endless cosmic cycle? Before you click away thinking this is pure science fiction, let me stop you right there. This mind-bending concept is actually grounded in real theoretical physics. And by the end of this video, your understanding of reality itself might be forever changed. Imagine for a moment that you could take a balloon and inflate it to the size of the entire known universe. Now picture that balloon collapsing under its own gravitational weight, forming a black hole so enormous that our cosmic neighborhood would be nothing more than a tiny speck within its event horizon. This isn't just wild speculation. This is a legitimate scientific hypothesis that challenges everything we think we know about the nature of existence itself. To understand how something this incomprehensibly large could even be possible, we first need to wrap our heads around what black holes actually are. Most people think of black holes as cosmic vacuum cleaners, sucking up everything in their path. But that's not quite right. A black hole is actually a region of space-time where gravity has become so intense that nothing, not even light, can escape once it crosses a boundary called the event horizon. The physics of black holes becomes stranger the deeper you dig. At the center of every black hole lies what physicists call a singularity, a point where our current understanding of physics completely breaks down. Here, density becomes infinite. Space-time curves to impossible degrees, and the normal rules that govern reality simply stop working. It's like trying to divide by zero in mathematics. The equations just give up. But here's where things get really interesting. What if our entire universe is actually inside one of these singularities? What if what we perceive as the Big Bang wasn't the beginning of everything, but rather the moment when a massive star in some larger universe collapsed into a black hole, and we're living in the aftermath of that collapse? This idea, known as the fecund universe hypothesis, suggests that every time a black hole forms, it doesn't just crush matter into nothingness. Instead, it creates a new universe, complete with its own space-time, its own physical laws, and potentially its own forms of matter and energy. Think of it like a cosmic Russian nesting doll, with universes inside universes, stretching infinitely in both directions. The mathematics behind this concept are surprisingly robust. When physicists run the equations for what happens inside a black hole, they find that under certain conditions, instead of everything collapsing to a point of infinite density, the extreme curvature of space-time could actually cause it to bounce back, creating what's essentially a new region of expanding space-time. This bounce could manifest as what we observe as the Big Bang from the inside. From our perspective within this hypothetical black hole universe, everything would appear completely normal. We'd see galaxies, stars, planets, and the cosmic microwave background radiation exactly as we do now. The expansion of our universe would make perfect sense. We'd have no way of knowing that we're actually inside a black hole in some larger cosmic structure. But the implications of this theory go far beyond just explaining our own cosmic origins. If this hypothesis is correct, then every black hole in our universe is potentially giving birth to new universes. Every time a massive star goes supernova and collapses, every time two black holes merge, every time matter crosses an event horizon and adds to a black hole's mass, we might be witnessing the birth of entire new realities. Consider the supermassive black holes at the centers of galaxies. These cosmic monsters contain millions or billions of times the mass of our Sun. If each one contains a universe, then those universes could be unimaginably vast and complex, potentially containing their own galaxies, stars, and maybe even their own forms of life. We could be living in a cosmic ecosystem where the creation of new universes is as common and natural as the formation of new stars. The scale becomes even more mind-boggling when you consider the implications for the black hole that might contain our universe. If our observable universe is about 93 billion light-years in diameter, and if we're inside a black hole, then that black hole would need to have a truly staggering mass. We're talking about something so massive that it makes the supermassive black holes in our universe look like grains of sand by comparison. This raises fascinating questions about the nature of the larger universe that might contain us. What would the physics be like in a realm where such massive black holes could form? What kind of cosmic structures would need to exist to create stars massive enough to collapse into universe-sized black holes? The beings living in that larger universe, if they exist, would inhabit a reality operating on scales we can barely comprehend. The theory also provides a potential solution to one of the biggest mysteries in cosmology, the fine-tuning problem. Our universe seems remarkably well suited for the existence of complex structures and life. The fundamental constants of physics, from the strength of gravity to the mass of subatomic particles, all fall within extremely narrow ranges that allow for the formation of atoms, stars, planets, and ultimately, life itself. If universes are born inside black holes and inherit slightly modified versions of their parent universe's physical laws, then over countless generations of cosmic reproduction, natural selection would favor universes that are stable and long-lasting. Universes with physics that allow for the formation of massive stars and black holes would be more likely to produce offspring, while universes with unstable physics would quickly collapse or fail to reproduce. This evolutionary process could explain why our universe seems so perfectly calibrated for complexity and life. We exist in a universe that's descended from a long line of successful cosmic ancestors, each one fine-tuned by the process of natural selection operating on a universal scale. But perhaps the most profound implication of this theory is what it suggests about the infinite nature of reality. If every black hole contains a universe and every universe contains black holes, then we're looking at an infinite nested hierarchy of realities. There would be no ultimate beginning or end, no fundamental base level of reality. Instead, existence would be an endless fractal structure, with universes inside universes stretching infinitely in all directions through scales we can't even imagine. The universe that contains us might itself be contained within an even larger black hole in an even vaster reality. And that reality might be contained within yet another black hole in an incomprehensibly larger cosmos. The chain could continue forever, with each level operating according to its own physics, its own timescales, and its own forms of matter and energy. This perspective completely revolutionizes how we think about our place in the cosmic order. We're not just inhabitants of a single universe expanding from a big bang. We're potentially part of an infinite cosmic ecosystem, where the birth and death of universes is as natural and ongoing as the life cycles of stars and galaxies within our own cosmic neighborhood. The theory also suggests that intelligence and life might be far more common than we imagine. If every universe can potentially give rise to its own forms of life and intelligence, and if there are infinite universes nested within infinite black holes, then the cosmos could be teeming with conscious beings operating on every possible scale and in every possible form. Some of these beings might exist in universes with completely different physics, where matter and energy behave in ways we can't even conceive. Others might inhabit realities where time flows differently, where space has different dimensions, or where the fundamental forces operate according to entirely alien principles. As we continue to study black holes and develop more sophisticated theories about their internal structure, we may find more evidence supporting or refuting this incredible hypothesis. Future observations of gravitational waves, studies of black hole thermodynamics, and advances in quantum gravity theory could provide crucial insights into what really happens when matter crosses the event horizon. For now, this remains one of the most fascinating and profound possibilities in theoretical physics. The idea that our entire universe might be contained within a black hole larger than anything we can imagine challenges our most basic assumptions about reality and our place within it. Whether or not this theory proves correct, It demonstrates the incredible power of human imagination and scientific inquiry to explore possibilities that stretch far beyond the boundaries of everyday experience. The next time you look up at the night sky, remember that you might be gazing out from within one of the most massive and ancient structures in existence, a cosmic giant that makes our observable universe seem small by comparison. And somewhere in the depths of our own cosmic neighborhood, new universes might be taking their first breaths inside the black holes we observe, beginning their own incredible journeys through space and time in an endless cycle of cosmic birth and rebirth.